Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the reverse Carnot engine, and it is also called as refrigerator. So we will discuss about the fridge system or refrigerator which we use in our house in the later part of this video. But first of all, let us discuss the refrigerator as a reverse Carnot engine. In fact, reverse Carnot engine is a device which works in the reverse direction as compared to the Carnot engine, and the technical word which is used for reverse Carnot engine is refrigerator. So refrigerator, we understand the refrigerator as fridge which we use in our homes, but actually refrigerator is the technical word of reverse Carnot engine. So this is a reverse Carnot engine, and you can see that the Carnot engine which is working in exactly opposite direction is called as reverse Carnot engine. So this is a source which is at a temperature of T1. This is at temperature of T1. Let us write it down. And the sink is at temperature of T2. And just in the opposite direction of Carnot engine, refrigerator is extracting some amount of heat from the sink, and then it is supplying some greater amount of heat to the source, and for that it is using some work done which is provided by the motor or the compressor. Okay, so we can see that if Q2 is the amount of heat which is extracted from the sink and W is the work required for that extraction, then the total amount of heat which is discarded to the source is Q1. Then Q1 will be equal to obviously Q2 plus W, and W will be equal to Q1 minus Q2. So this refrigerator extracts the heat from the lower temperature which is called as sink, and gives that heat to the source which is at higher temperature. In fact, many of the students have a doubt that why we are referring this as sink, although the refrigerator is extracting the heat from the sink. So the technical word sink is given to this reservoir due to the fact that its temperature is lower, and in this case the higher temperature is also of source, and therefore source is referred as source because its temperature is high. So we are not referring the reservoirs as source and sink due to the fact that they are giving the heat or they are absorbing the heat. In fact, we are referring them as source and sink due to the fact that sink is the reservoir which is at lower temperature, and source is the reservoir which is at higher temperature. So again T1 will be greater than T2, but the heat is flowing in the reverse direction. So we know that according to second law of thermodynamics, heat could not flow in the reverse direction by its own without any help of some external energy or work done. But in this case, you can see that motor or compressor is providing the necessary amount of work done to refrigerator to extract the heat from lower temperature to the higher temperature. Okay, so this is the reverse Carnot engine which is working in just reverse direction. Now we let us discuss about the efficiency. Now we know that efficiency is work done upon heat required for that work, but obviously it is not an engine because it is not providing any output as work done. Therefore we cannot refer it as engine, and obviously the efficiency would not be defined for this device. In fact, to measure the performance of this device, we would define another coefficient which is called as coefficient of performance for this device, which is beta, and it is beta is the coefficient of performance, which is the ratio of heat extracted from the sink to the work required for that heat extraction, which means that it is the heat extracted from the sink which is Q2, and the work required for that heat extraction is W. So beta will be equal to Q2 upon W, and we have already discussed that W is equal to Q1 minus Q2. So this beta would be equal to q2 upon q1 minus q2, and if we divide this q2 in the denominator, then beta would be equal to 1 upon t1 by t2 minus 1. And t1, this what we have written is the fact that q1 by q2 is equal to t1 by t2, and this relation we have already derived in the Carnot engine, and we have already proved this relation, so we can write it down as q1 by q2 can be written as t1 by t2, and t1 is the temperature of source and t2 is the temperature of sink. So the performance coefficient of the refrigerator is actually 1 upon T source upon T sink minus 1. Now let us discuss the practical working of the refrigerator or fridge which we use in our home. And obviously AC is air conditioner is also a refrigerator which we use at home, and the working of both of them is same. Now it is very important to note that the ambience inside the refrigerator is referred as sink, because the temperature inside the refrigerator is lower as compared to the temperature outside the refrigerator. So the ambience inside the refrigerator is sink, and the surroundings of the refrigerator, which is outside the refrigerator, are source. So this is source and this is sink. Now the things which we have to cool down is being kept in the refrigerator, inside the refrigerator. So let us suppose that we have kept a beaker which contains some amount of hot milk, and the heat is being released by that hot milk. Now what happens is the fact that you have seen a black round device which is called as compressor, which is kept in the back of the refrigerator. That compressor is a small piston type arrangement which juggles the gas and which increases the temperature and pressure of the gas. So that high vapor pressure gas is being injected in this pipe, which is also called as condenser, and this pipe you have seen is going through the fins which are connected to the refrigerator at the back side. You must have seen that if you open the refrigerator, then there are steel pipes which are connected like that. These are called as fins, and these fins are being connected with the radiator, with the condenser coil. And what happens that there is a fan which is connected behind this fins, which is throwing the heat outside this fins, and the heat contained by the high pressure vapor in the condenser coil is being thrown out through the fins by that fan, and this heat is being absorbed by the atmosphere, which is obviously the source in this case. Now this high pressure liquid is high pressure vapor is being converted into warm liquid after going through this arrangement, because its temperature decreases, so it gets condenses, and that condensed or warm liquid is passed through a expansion valve. This expansion valve is a coil type structure, and this coil, what this coil does, that it decreases the pressure of the warm liquid, and due to decrease in pressure, its temperature also decreases at constant volume. So it becomes a cool fluid, and that cool fluid passes through this fins which is inside the refrigerator, and these fins are called as evaporator coils. And you can see that the heat extracted by the hotter milk which is being kept inside the refrigerator is being absorbed by this cool fins, and this cool fluid which is flowing through this fins absorbs that heat and goes through this pipe again into this condenser compressor, and this compressor again increases the pressure of this liquid, and it creates it as vapor, and this process is repeated again. So all in all, what is happening in this case, that you have seen that there is a gas requirement inside the air conditioners and refrigerator, that gas is generally R3 gas or R31 gas or R14A gas. So that gas is filled in the compressor, and that gas is being circulated through this arrangement in the process I've already discussed, and that gas absorbs the heat from the sink, which is the ambience of the refrigerator inside the refrigerator, and that heat extracted is being released to the atmosphere, which is outside the refrigerator. So in this process you can see that the heat is flowing from inside to outside, and obviously the temperature inside the refrigerator is lower and temperature outside the refrigerator is higher. So heat is being extracted from a lower temperature to higher temperature, and the inner ambience is called as sink, and its temperature is obviously T2, and outer is called as source, and its temperature is T1, and T1 is greater than T2. So this is the complete working of refrigerator. Now also let us also discuss an important concept of defrosting. You must have seen that in the older days we have seen the refrigerators in which there was a problem of frosting, and we people used to shut down the refrigerator for a day to get it defrosted, because due to frosting its efficiency decreases. So this you have seen that there is some amount of ice which is deposited on the fins inside the refrigerator, and this is unwanted ice, due to which the efficiency of this refrigerator decreases. Now why efficiency of the refrigerator decreases? We can explain this by two types of explanations. We know that a ice layer has open cage structure, and therefore some amount of heat is being trapped inside the bonds of the ice, due to which the density of ice is lower than the density of water, as well as the air which is present inside the ice acts as a non-conducting medium for the heat, and therefore the heat flowing from the sink, which is inner ambience of the refrigerator, is not absorbed by the evaporator coils, which is connected inside the refrigerator. So ice plays a role of non-conducting medium for heat flow between sink and these coils. Therefore the refrigerator working efficiency decreases. And again we can also explain this by a technical analysis, that the performance coefficient of the refrigerator is 1 upon, we have already discussed that it is T source by T sink minus 1. So this is T source by T sink minus 1. So what happens, that due to the deposition of ice, T sink, which is the temperature of the sink inside the refrigerator, decreases, because ice is at lower temperature. So due to this decrease in temperature, this decreases, and this term decreases, and this complete term increases, and beta decreases, which means that due to deposition of ice inside the refrigerator, sink temperature decreases and the performance coefficient of the refrigerator decreases. Due to decrease in this performance coefficient, the refrigerator efficiency decreases and the cooling is affected. So to keep that efficiency at high value, we have to shut down the refrigerator for a day, and that is called as defrosting. But nowadays the refrigerators which we are using are frost free refrigerators, in which there is an automatic fan which is blowing some hot air on the inner fins or inner evaporator coils, due to which the ice this ice which is deposited over the coils is being melted, and that melted ice is in form of water. We are receiving that at the back of the refrigerator. So you must have seen that there is a tray which is connected at the back of the refrigerator, like that, and this tray contains that deposited water, and it is being continuously flushed out from the refrigerator. So this is the complete analysis of refrigerator, and in the next video we'll be bringing the explanation of entropy and the entropy in different processes. Thank you.